If f of x is the integral from x to x to the fourth of cosine, take the derivative. Well, they're calling on the fundamental theorem here. The fundamental theorem of calculus says if you go from any number a to x of f of t dt, if you do that and then you take the derivative of that integral, the derivative will cancel the integral, including the dt at the back, that's part of the integral, and you can just plug in that x and you'll get f of x. So that's what the fundamental theorem says. The derivative cancels integral, they're opposites of each other, and you just take that x and plug it in. But the a, when we say a is the lower bound of the integral and x is the upper bound, a means it's a number, not an x. But see, we have x's on both. So what do we do about that? Well, we have to rewrite it first. We've got to rewrite it because we can't have x's on both. We got to have numbers on one and then an x on the other. So, well, how do you do that? Well, then I'm going to say it's going to be the integral from x to 10, or what, any number you want, uh, cosine of t dt, plus the integral, then start at that 10 again and go to x to the fourth, your upper bound of cosine of t dt. Do you see how that's legal to do? Because we're going from, remember, the original integral is to go from x to the fourth. So I went, well, let's go. This could have been any number, and this is the same number. Okay, and so if I go from x to 10, and then from 10 to x to the fourth, I went from x to x to the fourth. I did the same thing. Could have been any number up to, like, if I go, I'm going to go from my car to my office, and then from my office to class. It doesn't matter so in the end, I went from my car to class, right? And when the trip is all said and done. So if I said, no, I went from my car to the football field, and then from the football field to my class, whatever. In the end, you went from your car to the class. It doesn't matter where you stop in the middle, right? It's the same thing. So, okay, great. Why do I do that? I'm doing that because I only want x to be on one side of one of the bounds, not both, because the fundamental theorem says x can only be on, in fact, it says the upper bound, huh? So I got to flip this one around, don't I? So let's do another step over here. This is again another rewrite step. You got to flip this first one. Why? Because the fundamental theorem says I need x up here in the upper bound. Okay. This is from 10 to x to the fourth cosine of t dt. Okay. So now it's looking good. Now it's looking like it's going to fit the fundamental theorem. It says if you go from any number to x as the upper bound, derivative cancel integral, plug in that upper bound, you're done. Great. All right. We can do that. So let's come on down because now we're going to take the derivative, right? So now they want f prime of x. So let me just write derivative and derivative and derivative. I'm going to take the derivative of everything. Here we go, the derivative. So what's going to happen in the first part? Well, we already said the derivative will cancel out that integral, and the x will just plug in. The negative will still be there, though. Negative cosine of x. And the dt is part of the integral. It cancels out as well. That was easy. Plus, same thing happened here, almost. The derivative cancels the integral. I should cancel that. Derivative cancels the integral. And the top thing just plugs in. But what if it's x to the fourth instead of x? Well, think if that's x to the fourth, can you just plug in x to the fourth? Yeah. But then the chain rule, remember the chain rule? Says you got to multiply the derivative of x to the fourth, which would be 4x to the third. Remember, we're doing a derivative. Whenever you do a derivative, if the inside function is anything other than a simple x, the chain rule says you got to multiply by the derivative of the inside function, right? Keep the inside the same at first, then multiply by the derivative of the inside, because the derivative of an integral is still a derivative, and so the chain rule still applies. So that means, okay, so it's going to be the cosine of, so plug in that x to the fourth right there, but then times 4x cubed, because that is the chain rule action. And so there we go. You can see it's right. They put the minus cosine at the back. Doesn't matter, front or back, whatever. Cosine x to the fourth times 4x cubed. There it is.